Hello, am I audible?
Yes, sir.
Go ahead. Okay, fine. Thank you. So, how is MLP going on? Is anybody unable to solve this activity question, practice question? Hello, how is this week going on? Week four, maybe previous weeks also for you guys.
Sir, week 4 is easier than week 2 and 3.
Okay, week four is easier. Okay, great. So many people, has anybody found difficulty in data cleaning, converting all the data to numerical type?
Yes, sir.
Okay,
I'm facing difficulty in week 2.
week two. Uh,
Yes.
any specific topic or anything? Um,
Like, sir, graded assignment. But it is available. It's collab. So I will see it. But it
okay,
was difficult to solve the assignment.
it was difficult. Okay,
Yes.
in that pipelines was covered. Maybe that's
Yes,
why.
yes. Yes, yes. Pipelines
Okay,
and that uh, feature uh,
TCS.
elimination methods. हाँ. Feature
Okay,
selections वगैरह.
TCS. Okay, okay. Uh, so anybody else found any difficulty? Okay, then we can start today's session. So in today's session, what we'll do is, let me first. So what we'll do is this is the data set. I can give you info this. So this is the link for today's data set. What we'll do is we'll do all the steps which are given in this lecture slides. Week one, right? So this lecture slides tell us about what should we do with the data. So first thing is like we look at the big picture, frame the problem, something like that. I won't go much about this, but then other steps, right? What is so performance measure? We'll see. So basically, this is a regression problem. So we'll use any one of this performance measure in today's session, and then okay. So this get the data. I mean, this is the data, right? You can download. I just give you the link for this. Uh, okay, if somebody is joined now. So we'll work on this. You can download this data and we'll work on this. Okay. And so all the steps, right? Get data sample, this data statistics, whatever given here. So then create test set, basically train test bed, right? So all the steps are given in this slide. The slide is this MLP week lecture 1 to 5. Okay, it's already shared with you. So don't. But this slide is very important. Why? Because this tells us what should we do when. So it's not like this is the only way you can do machine learning model training. You can change few steps here and there. Not, but not much. But this is something like a good, you can say a base you can have. And if you have a problem set, a data set, then you can go on and use these steps, and you might, you know, end up in a good state after this, and there is a chance you won't miss any step, something like that. So here everything, right? Step three, data visualization. We'll go into this also a little bit. So we'll see like how much I can cover in today's session, but we'll go. Okay. So for this, like there are many steps. Right? This slide is around 89 pages. So all the steps I written here, like this, all steps are there. Okay. So this all steps are there, and I will arrange it properly after the session, but you get it right. So how look at the big picture. These three questions are there in looking at big picture of the data. Okay, then getting the data. So what are the different thing in getting data? So check data samples, right? Of course, you know how to do that. That is not a big task. Data statistics, which features are there, right? Some of the creating train test split is also there. We'll do that. Then comes data visualization. So in this scatter visualization is there correlation metrics, some relation, basically this relationship between features, right? Correlation metrics comes under that. Then comes so this all steps are with you, and this is the way we will also follow this this data set. So we'll go to this project. I would say project to this, and we'll go something like this, right? So all the steps are there. We'll go. Okay, so first, so this is the data set. What I'll do is I will click on download, and I have the data. Okay, uh, whatever name is. So I will go here, and I will first reconnect. Connect, which are options for you. And I will upload the data set. Okay. So this is the data set I got. Uh, So first, what I will do is I'll just unzip it here only. You can unzip it already in your from your let's say what is file system and upload it any way you like. But I will just show you how to do that here. Okay, so we got train.csv. It will soon populate here. Maybe okay. So I got train.csv. This is the file which is shown here. This train.csv. Okay, I got it. I so this is how this data set is looking like. Okay, something like this. We have around 18 columns and uh, okay, 10 of okay, it's just showing that 10 of 18 shown, but something like this data set, right? Uh, so what I will do first is I will import pandas, right? Import pandas PD, okay, and for now I'll just import this. Later on we'll import whatever we require. Will be the data. Mm, yes. So whatever name is for you, use that. For me, it's trained to CSS. That's why I wrote this. So let's see what is the so next. So first thing is so get the data. Like so, framing the problem is it's let okay. We'll do that. Okay. So check the data samples. So how to do that? Tf.shape, right? Checking the sample. So I have around 9,800 samples uh, and of course 18 columns. So how my data set looks like is df dot head. We'll use head. Let's say 10. Okay. So this is how my data set looks like. Uh, cells. So what we have to do is since frame the problem kind of thing if I come, we have to predict the cells uh, column. Okay, this is the data given. Uh, dates. So what kind of data is given? So we are given date, order date, ship date, ship mode, custom ID, custom name. So segment, country, city, state, postal code, region. So different kind of categories are there, and based on this category, how much sales are going happening in a company or something like this that we have to predict in on one day, one order or something like that. Okay, this is the problem we got. This is the data we have. Performance measure we'll use. So based on the slide, we can see that we'll use let's say MAE R2 we can use R2 score because this is a regression problem, right? So we can use different MAE, MSE, something like that kind of performance measure for our problem. So this okay MSE, if this was a classification problem, then I would have used any one of the gradient recall FM score or something like this, right? So you know, right, that let's say if you got any problem classification problem and so let's say heart disease, okay, predict that if a patient has a heart disease or not, then we'll use recall as a measure because we don't want uh, somebody who has positive and not coming in our like evaluation. Okay, if somebody doesn't have a heart attack and is coming out in our we are predicting who has not who doesn't have heart disease and our model is predicting he has heart disease. That's okay, that will work for us because uh, later on he can have further tests and then that will prove that he didn't have the heart attack heart disease. Okay? But if he had a heart disease and our model says he doesn't have, then that's a problem. So for that kind of problem, we'll usually use recall as our like performance measure. F1 score is used when data is imbalanced. Okay, accuracy is used when we are focused on, let's say, positive side. So basically positive, true positive and true negative both. Then we'll use accuracy kind of. Yeah. So it's not like this is the like only reason we use this kind of classification measure or something like that. This also is kind of a domain expertise thing. So whenever you make your project in real life, somebody will be there who will tell you that no, I don't want precision better. I want recall. My recall. I want to improve my recall. You can do whatever you want, you can, but improve the recall. Or he might tell you, I want to improve my F1 score. So why he wants to do it? He has some business study regarding that. He has internal like domain knowledge, more knowledge about that problem set. So something like that. Okay. So for this problem, we'll use something like MSc, ME, or R2 score. Anything we'll use. That's not a problem. Okay. Uh, so list down various assumptions about the task. So what are these assumptions in our problem set? What can be that? So usually assumptions are we think that, let's say this is a or this is not a ordinal data. This is a categorical data or something. Right? So that's my assumption. Or I can assume that uh, something like sales on Friday is higher. Okay, if that kind of problem is there, then I have to make. So then, what is happening on all the Fridays? Give me that kind of output model or something. If you are making specific models, then we'll see something like that also. So this assumption is a thing like uh, it's this is also not a like I can't tell you in advance that for everything you should make this assumptions, right? You see the data, you feel something is there, then you can also write assumptions. So it's like a you can write assumption earlier, or you can write along with your data visualization and all along the steps also. Okay, so now this is the done. This is done. Like get the data. We got data, right? We saw how many samples are. Check the data samples. Features will do. Okay. So now let me come back here. So this is the step shape of data. This is how my data set looks like. Let's see how shall I write here info. And that will tell me how many known. Uh, so there are
Sir,
no null. Yeah. Hello.
increase the font size, please.
I sure. Okay. Better.
Yes, sir. Better.
Okay. So now let's see. Okay. So data info. So I can see that only one row has only one column has some missing values. Otherwise, we don't have any missing values. So I mean, this data set is okay, but see, we have missing values. Postal code. Okay. This is some kind of data for which we never do data imputation. Why is that? Because postal code has no relation with anything, right? What if mean, median, mode? Is it gonna matter anywhere? Like in postal code, at least no, right? So usually we don't do any imputation for postal code. What we can do is we just discard that sample itself, row itself, that we can do. Or what else we can do is we see what uh, so we'll come to postal code. Okay, this is a very specific feature which like we can't use one hot encoding on that. Okay, I mean we have to use that, but it's not that straightforward because for every order you will see postal code is different. It's possible. Like here we have it or not, I'm not sure, but it's possible that postal code is different for everything. And you why you wanna learn something based on postal code? I mean, you want to make your model learn something on postal code, and then it will change every time. So your model will not perform well, right? So we'll see how in what way the data is given. then we'll decide on this postal code. It's a very specific, feature, I would say. Uh, okay. Otherwise, we are not seeing any missing values. But let's see if there is anywhere question mark is given. Because if question mark is given, then I can't. Uh, it won't show as a null value, uh, but that is a missing value, something like that, right? I always do check it. That's why. So what I will do is I write df is my data frame name, right? So I'll write is n, and then inside this calculator, I will just give question mark. Or if let's say something else you feel that might be a missing value present, say -1, you can write -1. Okay. So what it will give is true, false, something. Okay. And now we don't know. So mostly false are being seen. So what we'll do, we'll sum it up. Each column wise, it will sum it up. So 0, 0, 0 means there is no this question mark or -1 present. To show it to you that it works, let me do it. What I'll do, I'll just search United States. Okay. Uh, Let me search United States. So df dot is in, and I'll write United States. Okay. So somewhere you are seeing here true, 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 right? If I sum it up, you are seeing that all the, so basically uh, one country we got, right? 9,800 United States only. So basically this data set is from United States. Like this is the only country they are shipping their orders or something like that. But what I want to show is if you want to search something, some value, some like question mark -1 something, you can use this df.isin, and you can give multiple values also. United States, here I will given this. Let's say if I want to search this Henderson, okay. Also Henderson is city name. Okay. So if I want to search United States or Henderson, okay, not and or. So what I'm seeing is I'm getting 9,800 units for United States and 51 is for Henderson. Okay, so it will search both of them. Okay. So this is the only one we have null values. Will Should I take it first or should I show it to you later? So, so there's one thing you've seen that order date is an object, right? Object. This is order date and this is the object. So this is not a good thing. We need to change it to something else. Like what that something else is? Date time 64 ns. You will see somewhere. Uh, time 64, right? So this is in this format you have to change your data set. So how to do that is I will write. So let me take one string. This is the date. Say, this is how my data set is. Date is this. So what I have to do is pd dot to date time. Okay, and string. Okay, so now I got my date, and this will be in this format only. So here I am not sure. Is it given in by or in up to LTF dot uh, 12, 17. Okay, 17. Okay. From here I can say that I got DDMM by kind of, okay, DDMM by kind of dates, and was it able to correctly do it or not? So now I got Y MM and DD. Okay, so this is the date. Here the date is in middle, and here the date is at last. So I will show it. So let's say if I choose this one, okay, and this format checking is very important, right? Because we use GTMM by, but somebody is using MM something like that, right? So you can see we got error or something like that. Passing date is DTM wire format when uh, day first is false, something. So what I have to do is day first true. I'll do that. It will do. Okay. So this was required. Now I have to do that all the thing for shipping date, ship date, order date also there. Let's do it. So what I will do is I will write DF. Instead that I'll give column name and then I will write this all the thing. Dot to time repeated for for okay. I got this new column. Means not new yet. I mean, we got this all the dates converted to daytime. So now you can see D type is daytime. Okay. But one thing is what I am done is I haven't changed my order date in my uh, in my data frame. Like there, it's already it's object still it's still an object, right? So I have to change that. So what I will do is I will do is is take this part, put it in front, and equal to now it will come. Same thing I have to do for this ship order date is done. So I'll do the same thing for ship date. Yeah. Now if I write df.info, you'll see that this order date and order ship date are in date time format. So why is that important is what I can do from this. Let's say if I write df and then order date dot tt dot uh, so uh, that date from date time. So write this tt dot date. Write it. Date. Okay, got dt dot day, dt dot day. Okay. So now, as you can see, I can extract each thing, right? Let's say if I want only years, not month, not day, then I can do something like I can write year, and I will get year. Okay. So this all years are there. I can make a new column out of it of order year. So let me make it. Okay, DF order year. So you are seeing that currently I'm doing everything, not on my train test bed, but everything, right? Why is that? I'm just making everything in a correct format. I'm not doing any, data pre-process. Like I'm not replacing null values or something like that, right? I'm just making everything in a correct format. Then we'll do train test split. Then only I can do other steps like if I want to impute something or something like that. But here, what I'm doing is I'm just correcting the formats. That's all. Uh, it's easy. That's why I'm doing it. Otherwise, I have to do it for both of them, like train and test, and it won't change anything, right? But if I do imputation, then if I do it here and not do it later on, then it will be a problem, right? Because it will learn from my train data, and then the learnings will be passed on to my test data also. But here I'm not learning anything, just changing the things and that's all. Okay, changing and everything. But if you want, you can do it after the interest split also. It's not a problem. Just change for both of them.
Hello, sir. Am I audible?
Yeah, you are audible. Tell.
Just a small doubt, sir. Sorry, I missed some part in between. In fact, I have a doubt related to this train and test. When to do pre-processing, whether we are supposed to do pre-processing of train and test separately, or we have to combine it, because both thoughts are prevailing. Like I was watching some videos on YouTube where it has been said that we need to combine train and test, and then we should do the pre-processing. Whereas in one of our live session, it was told that we are supposed to do pre-processing separately, but again, in one of the project session, it was said that we need to combine the data. So, bit confused, sir. Could you please clarify, like, what is the ideal approach?
Okay, so what happens is when we have very small data, very small means it's 100 samples we have, right? In that cases, we don't do trend test bit. I mean, why is that? Because if I do, let's say 70, out of 100, I will choose 70, then do it. My model training and something, then my model will not get trained at all. Okay, something like that. So to prevent that, I'll just use all the data to it, and at least I have now model, trained model, something it got trained at least, right? Something. So because I have constraint there, I don't have any data, very small data. In that cases, we don't do train. Otherwise, we'll do it every time we do it. Okay. And what else? Other cases possibly is when we don't need to do train tests before preprocessing is. I mean, I don't see any that kind of conditions, but what I will tell is, so why we do train test it is, so let's say if I do train test it, okay, so now 70% is train and 30% is test, right? So what we assume? We assume that this test data after my model was getting trained, right? After model trained, what I will do is this was the data which I didn't had. I will just assume that this data I never had it before, something like that, right? That is my assumption that this is a new data. Assumption will be that this is new data, never seen. I have never seen it before, never used it anywhere, something like that. And on that, I will use my trained data. Sorry, model. Okay, I will apply my model. Apply my model. So now I have some outputs, right? Some output I will get. But the good thing is I already have output for this, right? Something will be there, right? Y column. So this output means Y prediction. Okay, let's say I will write Y pred. But I have already Y true. So what is the true possibilities, right? What is the truth? I have truth. Then I will compare both truth and prediction, and I'll see how my model is performing on unknown data, something like that. That's what I assume while making train test split. Uh, so uh, so then I feel that let's say I get a very good accuracy or very good R2 score or something like my performance is good, then I will really apply on unknown data like futuristic data for which I don't have white true, for which white true is not available, something like that, right? Not available. I will apply on that kind of data, and then uh, it will give me some output, right? It will give me some output, then I will see that okay, this is the output. This is gonna so let's say if it's a data of customer, will that customer buy this product or not? And this is my model will say yes, he will buy it. So then what I will do is I will recommend him. Okay, recommend him. And then let's say I recommended him and he didn't bought it. So then what? Then I was wrong, right? So something like that. It happens. Many things got recommended, but not everybody will buy it, right? So that's why we have this why train test splitters to check uh, to check my model how it will perform on new data, which never I have seen before, right?
Sir, this role of train and test is clear. Like, what is the importance of train and test data?
Okay.
My question was that, say for example, I am participating in a competition on
Okay.
Kaggle, okay,
Okay.
and I have two files. One file is train file, and the other file is
Uh,
test.csv.
okay.
So
Okay. I
whether
understood. Yeah.
I am supposed to combine these two files first and then do the pre-processing, or am I supposed to do pre-processing separately on my train data and separately on post data? Because I am getting both
Okay.
kind of answers.
Okay. So I
Yeah.
understood your problem. The reason is it's a Kaggle competition. Okay. So what is Kaggle competition? What people do is I would say this is a crack. This is a hack. Okay, hack. What is hack? Kaggle hack, I will say. Okay. What people do is uh, they Kaggle hack is they combine train and test data. Okay, then they impute it. So what happens is they get better imputation, right? Better thing, more data. They impute it, pre-process, clean it, they combine it, then do it, and then they split again, and then they train it to get better results. This is a hack. Okay, this is a Kaggle hack, I would say. But this will work on competition. But in real life, you should not do this. Like in when you are a machine learning engineer, you are making a product for your company or something like that, then you should not do it. It's a Kaggle hack.
Okay.
Okay.
Thank you. Got it. Thanks for this insight. Yes. So what you are saying, in real life, we should not merge train and test, right?
Yeah. In real life, you
But
should not do that.
but
This is a Kaggle hack
but
to get the better
but
accuracy and better results. Yeah.
but in one of our live session of a project, it was said that we are supposed to merge first train and test and then do the pre-processing and then again split. But sir, even in Kaggle hack also, when we are merging train and test data, so my test data is not having the output available in my train data.
Yeah. We
So
don't require output. That's what. No. See, what they do is they merge it. They merge it. They don't need output. When you will require output is for training, right? Model training. But what they do is they
hmm.
merge the train and test, they pre-process it, clean it, everything they do it, then they again split it, right? They split train and test again. Then on
So
train data, they build a
while
model.
so while merging, they drop the output variable also from train data or what? Do they drop
No,
it?
no, no. Oh, yeah, while
Because
merging, they
my
drop
train
it.
data will be having.
Yeah, they drop it.
Acha,
They
they
drop
drop it.
by further. Yes. They'll drop the labels, I mean, why, and then they do all the pre-process. Okay.
And then again, train data be split into train and evaluation, right? Train and validation or evaluation.
Uh, that is your choice. I mean, not choice, but in Kaggle competition, it's true. Yeah, that's not a choice. In Kaggle competition, that's not
Okay.
a choice. You have to make validation sets to get
Okay.
the accuracy, right, or something.
Okay. Got it. Thank you, sir.
Yeah, so now, so what I'm doing is I'm extracting this year, in which year this shipment was done, or order date year. Okay, I'm extracting this and storing it in order year name. So this is the name I have. I'll just choose it and I'll do it. I'll run it. Okay. So uh, I'll just delete it. Okay. If I show you now my df.head, you'll see one more column. This is the order year, which was extracted from this order dates. Okay. Same thing I'll do it for ship year. And then I will drop. So what happens is we can't train our model on dates. Our model doesn't understand dates, but date have years, months, something like that, right? Months, something like that. So same thing I will do with. Now, the question is, should I keep months also or not, and days also or not? For that, I don't have like very, what is clear answer that we should keep it or not. It's a choice. If it works, keep it. If it doesn't work, don't keep it. Something like that. Right. Ship here. Now I'll have one more. Yeah.
Sorry to interrupt you. So do you mean like every date we have to break into pieces, right? Day
Yes.
wise
Yes.
and month wise and year wise.
Yes.
So
You have
we
to
have to
break
make
it
a
if you
calculation
want
based
to
on the
use it.
day. No,
Yeah.
if we have to make the calculation based prediction based on the date, like it's a time series data. So in
Yes.
that case also we have to break all the dates, sir.
Yes. If it is a time series data, then you have to break it. Everything.
Okay. So there is no more accept date as a parameter.
Yeah. Yes. Model doesn't take it. So in sklearn, it doesn't take it.
Okay, but like you're saying like okay, we break the date, fine, but we didn't find okay on this date this was the value, on this date this was the value. We have to make the prediction that way. So what will be the on that day? What will be the value? Anything?
Okay. So, but you will get a new column, right? New date column. Your voice is a little bit breaking, but uh,
Sorry, my net is not good actually.
okay. Write in chat box what you are saying. I'll read it. Okay.
Okay,
Somebody wrote
sure.
also. One side, okay. Where can you find these slides? Okay, this slides was okay, so this is this week one. Okay, week one. Uh, week one. Lecture resource from instructor. Resource from instructor. Week one. 1 to 5. You will see the slides there. It's already there. Mhm. So for time series data, you have to break all the things into year, month, dates, something like that, right? That you have to do for time series kind of data problems. Mm. So now let's say if I want to see, let's say my question is, uh, meanwhile, the, he writes the question or something. I will, let's say in month of say July. Okay, July and years are what I can say is 2016. Okay, 2016. Uh, how many? What I say? How many samples I got? Samples I got. Samples means rows. Here it means rows. Sample can be anything, but here I mean is rows. How many rows? Let me write that. How many rows I got in month of July 2016? How will I do that? Okay. So why is it important? If you ask, then then it's important if your use cases is based on some July month. Let's say before vacation, uh, a month or date is coming. On that day, is sales increasing. On Sunday, let's say in Fridays is my this sales increasing, something like that, right? If you want that kind of thing, then you should know how to uh, get rows and all using this dates. Using dates, right? Which month, which day, which year. So you can combine, let's say, July to August month. How many cells is happening, right? Here, cells. This data about cells, and each thing is, I guess, containing a cell. A, a cell was happened. How it happened, like from where to where they send it, something like that. And if you want to see how many cells are happening in a month, of a year, then how will you do that? Is any month is getting more? There are many questions, right? Which month is having high salary, high sales? This which one has highest sell? What is sales trend? Right, trend means can be month wise, can be month wise, can be year wise. Year wise. I will not answer all this, but these are the questions you can ask from a data set. Cells changes, increasing, decreasing, how many cells are happening. You can do total cell month wise or something, right? So there are many questions on cells and date. When the date and times comes in your data, the number of questions you can ask from the data set are huge, very huge. It can be anything, right? So try finding this answer if you can later on, like after the session is over. But uh, if anybody has any idea, this first one, we'll do it here. Okay? How to get this July? So July is 7, right? July is 7. So if you see, so here I use year. Right? So, so what I'm talking about is order year. Okay, let's take it for order year. Maybe let's say if it is getting changed for ship year and months, right? Months are changing for ship year, then we can't do anything. But order year, order month, order year and month. That's what I'm talking about. Order date. Okay, I love that. How to make a decision based on date if the dates belong to different years. Dates belong to different years. I mean, which for sorry, this Hari
Yeah,
Shankar.
yeah. So why I'm asking, because you have break
Okay.
down that date site, DDL
Yeah.
different, MM different, and year different, right? So there'll
Yes.
be the
Yes.
three columns like that, correct?
Yeah.
So actually, we are not making any kind of prediction if you break it down. Okay, suppose
Yes.
if you take the share market data, okay, so
Yeah.
every day it changes the things. Okay, so mostly the
Okay.
data is based on the dates in that case.
Yes.
Okay,
Yes.
so if I want to know, okay, what is the value of maybe next year or maybe tomorrow, what is the value? In that case, the date plays a critical role, sir. So I mean,
Okay.
how it is important to break it down in that case when it is a critical element of the
So,
data.
okay. So what we usually do is we break it down. Okay. Date, months, and years. Now we have it. Then we'll train the model. Okay. And we'll see, is our model, is in is this date column or month column helping our model or not, right? So on model based, there is feature selection techniques, right? On based on model that will apply. We'll see if let's say it is removing date as a important feature, then we can't do anything, right? Then that's it. Like then
But
that means for
in
this
that
model,
case,
date was not.
sir, it will take these three columns, right? DDMM YY is a separate column
Yes.
and separate feature. I mean, so
Yes.
it will combined, but it can't. I mean, I doubt. I mean, how it will behave properly. But yeah, it's worth to check. I will check, sir. No problems. Thank you.
Yeah. So see, this machine learning is not a I mean, your questions is okay, but there is no straightforward answer to this. Like you have to try, test. It works, then works. It doesn't work, doesn't work. Like something like this. It's always that answer for me. I mean, when dates and times and comes up, there is no correct answer. Okay, something like that.
Yeah. Okay, sir. Thank you.
Okay. So now, so is anybody have idea how will I do this? Let's say in month of July 2016. How many? Okay, how many rows are from this July of 2016? How many rows are? How many rows are from? July, July of 2016. How will I do this? Others you will try. Okay. Trend means you have to plot the maybe line chart or something. Okay. And see, or bar chart will also work. No? So likewise, I have to extract month also, right? So let's see. So first, I'll write month, and I will get the month. You can see 11, 6, 10, 5, 5, 1, something, right? So if I write unique, then you can see I got all the months. Maybe I'm not missing any months, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. Length is 12, so everything is covered. And July is 7, right? So what I have to search is DT month is equal to 7, right? Something like this, right? True, false, false. I'm getting, and I can do. I can write here. So this all months will carrying order date from the month of July 7, 7, 7, 7. Okay, around 697 rows I got. Okay, I hope you understood how I did that. What I did here is important. Okay, so for now I'm extracting years only, but you can extract months also when you train model later on. Okay, to try to improvise this data cleaning part. Now, let's see. So we have if I write columns, you'll see it's all columns are there, right? So which column do you feel are least important, or I can just remove it? That is not contributing anything, or
Row
will
ID.
not contribute anything. Okay, row ID. Okay, we will remove this. Anything. You can see here. So if you want reference into it,
Is the customer name? Does it play?
no, yes, we can remove that also. Right. Right. So so this is how my data set is. Looking like from here. Order ID is there, which will also not be important.
So
Okay.
postal code also doesn't play any role, right?
Yeah, it usually doesn't play a role, but
Yes.
because this is
We
a
went.
this is sales data,
We
right? So
no,
let's say
we
if at one postal code, many cells are like many things are going there, shipment, like many shipments are going there, then it might become important. Let's say two, 6 places, 7 places, more number of shipments are happening, then that postal code will become important in our sales data, right? So where we'll predict this cells, right? This is our output. What we say label column, right? Something like that. So we'll see this postal code. We'll see something about that, but let's see. So we'll see. I'll keep it for now, and I will use it also. Okay, I'm not gonna remove this. What else we can remove? Order ID we can remove, right? Because based on order ID, we don't understand machine also don't understand what is order ID has anything to do. It will be just numbers, right? Some numbers. Random generator.
Order year.
Order year is important, right?
No,
Uh,
we have order year and shipping year both.
yeah, we have both. We'll see. If it has, let's say, both are very similar, like 100% similar, or it's the 90%, then we can remove one thing. I just kept it. Okay, we can remove it. Yeah, true.
order
You are
ID is
right.
not important.
Order ID is not important, right? Because for every order, ID will be different.
different, correct. In fact, order date also not is not important, sir.
Yeah, you can remove it. So now I can remove it because I already extracted years out of it. Okay, I don't require this order ID, order dates. But if you are planning to use months also, then uh, then you first extract the months, then remove it. Okay, so we'll remove this order date, ship date. Both will remove. Okay. Order row ID and order ID. Order date ship four this four things are this four things will remove. What else we have? Customer ID, right? This will also remove. Customer ID, customer name. Okay, most of things are going to get removed. Segment. Segment is consumer or maybe other segments are there. Central. Wait, that is not segment. Segment is consumer, corporate. Okay, we'll keep it. Okay, we will not remove it. It feels important. Country will keep it or remove it. What should we do in this case?
It's a country
So,
should keep, sir.
So in
true.
this
We
case, I
should
think
keep
we
it,
should keep
but
this because United
sorry.
States is one country, no? Just one country
Yes,
we have. So we should
yes,
remove
yes,
it.
yes. In usual cases, we keep it, but here, in machine learning, you'll see that if your data doesn't contain any variance, okay, zero variance means there is nothing is changing in that unique, only one thing it is contributing, right? Same thing. Then that is not an important feature itself. So that's why I will remove it. Okay. So if you see when you count, you'll see only one thing will come up on the United States, right? That is the only thing I have. If I see there is nothing it will contribute to my machine learning model learning, right? Everything is coming from same thing. So we don't require this column also. So I'll remove it. Okay. This is not true for every use cases. Okay. Don't remove country everywhere you see. But here, because we are in only one value, that's why I remove city. City, I have seen two, three different Texas, Venezuela, okay, California, okay, that is state. Okay. Philadelphia, Los Angeles, Grand Prairie, something, right? So I'm having, you can see different kind of cities and states also. So I'll keep both of them. I'll keep postal code also. Region, let's keep it. East, West region, North, Central, something like that. Okay. Product ID is also not important. We'll remove that. So, product ID also. Product ID. And they have category. So furniture or maybe this is one technology of the supply. Then we have subcategory also. I'll keep this. I'll keep category also. Product name. Product name is also not important. I'll remove this also. It's not important. Cells is important because that is the output. Product and order year and order ship year. Let's keep it because we extracted from the dates and we are going to use it for in our model training. Okay.
Sir, why product name is not important, sir?
Okay, good question. Uh, I would have explained. So product name is it's important but not important in that cases. I'm already getting whatever product is in subcategory. Like so, you can see Bush, Somerset collection, bookcase, something, right? So at least I'm getting category, some kind of data. I'm already getting it from a product name. That's why I'm removing it. And second thing is, if I want to keep this product name, then I will require to do text analysis. Some kind of text analysis is required. Okay.
So,
Uh, True, it's not like I can just remove it without uh, carrying anything. But uh, and it's an important feature. You are right. But because I'm removing, because then I will require to use text analysis. I have to do some NLP, use it and extract out the important words. Okay, carrying. It is carrying. Or I have to use something else.
Okay.
Yeah.
Okay.
So it's true. Like I just can't remove it very easily. But here I'm using it because I'm already extracting a few information from this category and subcategory and getting it right. So you can see here, let's say this Microsoft Natural Keyboard Elite, right?
Hmm.
Let's
Okay.
say if this product is very important to me and I'm removing product name, then that's a bad thing, right? So before removing, let's see what kind of product names we have. If we have, uh, if we are having multiple products, sorry, same product selling too much, then we'll keep it. Okay.
Okay. Since category and subcategory is here, maybe those information is here, so we may drop. So you had an idea of dropping product name. So if category and subcategory is not there, so we will not drop. Is it like product name?
Uh, uh, True, not true. I mean, it depends. Uh, it depends, like what you can extract from the product name. If you can extract any useful kind of thing, right? That is like your knowledge, okay, domain knowledge or something. If these names are giving some uh, good information,
Hmm.
and if you are able to extract that, then do extract that. And also the extracted data should be useful also. If it's like useless, then again it won't work, right? Something like that.
Okay. Okay. Thank you, sir.
Yeah.
So can you group by same product name, group by city also, sir, here in the code?
uh, group by
Yeah,
group
product
by what?
name, group by city.
Group by city.
Yeah.
uh, can do that then,
Do we-
but then what will happen? Mm,
No, no, I just want to know, do we have any code, like, I mean, any
yeah,
function
we
ordering
have
product
so
based on city, like how many which cities are ordering more products? I mean, similar products, sir.
okay, which city is ordering. So when I place here, uh, of have to use it. Let me see how to. Here dot group by and just go here and try this column name. What I require is you're asking for product city.
Yes, sir.
Why? Okay. Generate object and there should be something. Group by by B. Can write something. It's just check. How will you use this? Uh, I have here, and if I do group by uh, object at something, and I'm not sure how to.
Okay, sir, we'll find. Sir. You can move on, sir.
For group in df.group by, I have to write something different. Show something in getting groups. But this is too much another way. So if you see some with generators and all, you have to use loops. Or there are other ways also, but generally I use loops. The thing is, we'll get this in this way. It's very messy. Uh, or I can do this. Okay, that's good. Then time by time. Is it grouping? No, I think this time out. But I'll repeat it, okay? Print group. You can do it. Mm, we'll just write comment, improvise. Otherwise, somebody will get confused. The syntax are really hard to remember, so that's why I also don't remember. Usually I do search it and just put it. So where was I? I was going to drop this all thing. Let's do it. Just let me make array after it. I will name this something like drop columns. Okay. And then I have to do is df dot drop. I will write drop columns and I have to give access equal to 5. Now my data set will look like something like this after dropping, but I haven't stored it anywhere. So let's see if I'm doing it correctly or not. Uh, so I'll write just df dot columns or df no d1. So am I doing it correctly? Yes. Then I'm taking care. Custom name also nothing says admin I'm taking. Country I remove it. City, Kentucky, postal code I'm keeping it. Region, category, product ID don't require. Category bookcases. Sales order. Okay. So I think I did it correctly. There is no error. This is just for confirmation. Okay. Please to confirm before dropping anything. That's a good habit. I'll just remove that. I'll store this in. I'll call this as TF2. Okay. Now, I'll just write is null dot sum to check the null values. That is in postal code, I guess. Okay. 11 around the columns are there, which doesn't have postal code. So we'll come there. I'll come there. What should we do about that? Or let me just go there directly. Good thing. Okay. So okay, let's go to what is postal code and how to deal with this. So what happens is when we do let's say model training or something, usually postal codes are not similar. They vary too much. Uh, so but here you can see this first order and second order are coming the same postal code. So if first thing we'll check about postal code is if this kind of data is there, what we do is df2 postal code and I'll write just value counts. Okay. to see that all my orders are not going to different locations every time. Okay. So what I can see is around 253, 225, 220, something like this are going to this places. Okay. So now here I will, what I can do is uh, I will tell my model that uh, top says the top eight, whoever is coming in top eight locations are important to me, are important uh, to my business, something like that, right? So to my business, everything else is less important, I would say. Not important, less important, something like that. I can do something with this. So what I mean is, I will just keep this top eight columns. Okay, top eight, not so top eight. This postal code values, will keep it, and everything else will be other. Okay, so uh, let's do value count dot values and eight. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these eight values are important. I will just keep it. Uh, not this. Sorry, what I required is index, not values. Okay, so this six values are required. I will encode it as categorical encoding, one hot encoding. I'll apply one hot encoding on this, and one more column will be there, other. Other. I will apply one hot encoding. We can do something like this. If we have postal code data, okay. Removing is also an option. I'm not saying you can't remove it. You can remove it, but so what? Uh, this thing, this step is saying that what I mean is I am telling my model that top eight locations are important and other locations are not that important to my business. Okay, so that's why I'm doing this. It's just my thought process. That's all. So we'll do it. Okay. What? So now what I have to do is accept this. Everything, every other place I have to write other, or maybe let's say anything, right? Other. I have to write other at least. So how to do that? How to write every other place other, like every other row which is which is containing not this value. Okay, not this value. Then we have to replace it. How will I do that? Anybody have any comment?
Like comparing this value.
Yeah, true. But like what I mean is, do you have any like code or so? Are you doing alongside? Then you might have. But if you are watching, then you won't be able to give correctly answer like write this, write that, something like that. I was expecting from that. Uh, let's see. So just put that postal code dot is what I mean is not is not the same. Okay, I have replaced this to only. So what I can do is and other will not be there. And if I write let's say not, will it work? No, won't work. It's not it also. It's not. It's not. Okay. Okay. This will probably not work. False, false, false. True, true, true. Something like that. And can do this. Opposite of that. So this true false, I have to convert it to right. Now it's reversed to that. So so if I write this, you'll see falses. But if I do this, I'm getting trues. So this is what I require, true false something. Now I can use this condition and I'll just write df. Sorry, not df. I should have wrote df2 and used square brackets. And I'm having it. So this all codes, postal codes are, or I can write just postal code here, uh, and this all values are there, which are 8223. Length is also there, right? So you can see something like this, right? So this all are other. I can put all of this as other. I can do. So now how to change it? How to give this value as other? Is there maybe can do something? Okay, sorry. Pairing. A value is trying to set on copy. Okay. But I guess it did. Okay. Okay. I'm getting other. So if I do now value counts. Okay. I'm getting it. Others are this much. This all are my other value counts. So see here my bias. Here I'm putting some bias, right? This bias. Now is it good for my model or bad for my model? That I can't judge without training model. So I've trained the model, then only I will be able to know that what I did was correct, or should I have removed it, or should I have done something else. So till I don't get my best model, I'll just keep doing something. I'll do something, change it, doing something, change it, and see all the possibilities. If it works, I have to like read research papers, read some other books or something like that, and then I have to make my model better. Okay. Uh, so now I need to do is I have to apply this one hot encoding. So here, standard class, second class. Okay, here also one hot encoding. City is also one hot encoding. State is also one hot encoding. Uh, Postal code is same. Region is same. Furniture same. Category same. Okay, so everything is category, right? I don't see any ordinal kind of data anywhere. So after I will apply one hot encoding, I will get I guess too many columns. Let's see. So df dot select in type df and I will type exclude equal to exclude equal to number. Whatever. I must select three types. I'm getting this menu dot right, any unique, and this many uniques are there. So in city, 529 uniques are there. If you see, let's see, TF2 city, or let me do value nodes. No, whatever. Okay, but let's see. Okay, 8, 91, 7, 28, something 529, right? Length is 529. So I am getting too many cities. So I'll get 529 different kind of cities, right? Again, I don't want that many number. So same thing I can do what I did for postal code. I can do something like this. Okay, I can do it. I can do this. Make everything other and select top few number, top let's say five number, top five cities. And same thing I have to do for state also, top five. Subcategories also there. For this, take one paper binder, copier, finishing arches. Okay. So okay, one thing which I didn't do is okay, there's one mistake I did. Sorry. That mistake is so dropping column is okay. I can do it before train test bit, but this part, right? This part, this I'm changing to other. I have to do this for test data also, right? Because whenever I get test data, let's say if my test data is containing some other value, like, other than this six, 6, 7, 8, six, this 8 values, then I have to change that to also other, right? Then only my I can see my model is giving some output. So I should have done what I should have done is here somewhere, here somewhere I should have done train test it. So let me do that here now. So how to do that is sklearn dot model selection import train test split, and I will write as df2, and I will give train size as say 0.3. Random state is optional, but let me keep it. I'll choose a set value. So any number will work. So now I have to give some name, right? So let's give train and test. That's my data names now. Train and test. Got in we can do train dot shape. Test dot shape. Um, what happened? The train size is responsible. Now better. Or should I keep 0.8? Keep 0.8. Now whatever I did should have done that. What train? Um, train. Uh, this is also train. Okay. So are you getting what I'm doing? Like, this data set is little bit off. I mean, this is like beyond, beyond the teaching of machine learning course. That's why maybe you're feeling what is happening, because most of the features are containing uh, categorical data, right? But the cells is the thing we have to predict out of all the categorical data. This is a little bit off example, but we'll do it. We'll do something. We'll make a model out of it. Now what I require is, so this many counts are there. For each thing, I need to do same. Paste it. Mhm. Times two. Uh, Here I will write. So what is this? This is the thing I should write. Right? Topic. And now I have to do it for. So I can make a function which will define remove what I'll say unimportant values or replace values. Okay, replace values, something like this. I'll say, and I have to give one is data, and maybe column name. Okay, column name. I will write that. So what it will do is, well, data. Column name, data, data, name, value count, stop 8 for everything, and change it to other. And I will write return. So that's my function. What is the mistake? Okay, is equal to other, then I could use return data. Yes. Okay, absolutely. Let me call this replace values, and I will give df, no, not df, to train, and the column name will be city. Let's do it for city.
So column names would be in quotes
Um,
in the definition.
okay, here, right? I should. um, Okay, at least change for city. But here, okay, change for city also. But is it like string dot City. Okay, so change for city also. Now I need to change it for state also. Okay, and I will do same thing for this subcategory also. Should just copy it here 3 times and choose state and subcategory. This many. So this kind of warnings we can ignore that. But after this all, you'll see we'll get train.head something like this. Uh, this not the one right. Other others. Okay, I can see others everywhere. Now, when I where was that? Okay, here. If I run this, we can see at least manageable categories 4, 3, 8, 9, 9, 9, 4, 3, 9, 9. Right, 9. Why I'm getting 9 in this is because 8 we chose and other is also there, right? So for each category, other has different meaning, right? Not same meaning. So city other is other city, another city other than what we had chosen, something like that. So let's do apply one hot encoding now. So from so should I use pipeline and show it to you, or without pipeline you want, which way you want?
Try with
Mm,
With
pipeline.
pipeline.
With pipeline.
okay, okay, we'll do that. Then let me do scaling also. So so about scaling is there is one thing about scalar is we usually do scaling to numerical data. And not categorical data because we are already converted to 0, 1 or something like that, right? 0, 1 or something like that. But let's say if you have applied this ordinal encoding, then your data will be like 0, 1, 2, 3, 4, 5, 6, 7 at whatever. So you can apply new mean max scalar to that. Mean max scalar is okay to apply on that. We can apply mean max scalar to this also. Yes, this ES. Because so basically what which we choose when is there is no like particular rule, but when something is not following Gaussian distribution, years are not gonna follow any distribution, right? So for that we'll use mean max scalar. That will work better than standard scalar most of the time. It happens. Okay. Now what I need to import is from sklearn dot uh, can't use pipes, but I can use is column transform. I mean, using pipe is not required, right? So you know, right, that pipes we will use when we want to do something serial wise. So what I mean serial is, let's say if I want to do, I wanted to replace null values, and then do scaling, right? So this is serial. I will write and then this is because this is serial. serial command, right? So for that, I will use pipeline. But if I want to do one-hot encoding and min-max scaling to different columns are changing, then I should not use pipeline. I will use column transformer. There is one thing called feature union, but the thing is, I haven't used that much. How to apply that, or because most of the time this pipeline and column transfer will work for me, so that's why I haven't tried that. So this will work when we want to do, when we have, you know, parallel something. You know what is parallel and serial, right? Or is there any doubt in that? So here what we are gonna do, parallel serial, one hot encoding to different column, mean max scalar to different columns. I guess you know that we are gonna use parallel, right? Column transformers. Let's do it then. Now, how to write a column transformer? So, column transformer will take array of transformer. So, what it will take is it will take not like this. This there is one variable called transformer. Here it will take array, some array, right? Let me give a name of arrays. Uh, let's say uh, what should I choose? TRF. Okay, I'm choosing TRF as a name. There is no TRF, so I'll create it. This variable. This should be array, and to write one transformer, you have to use this curly brackets. What is this? Curly? No, this is not curly. Round brackets. You have to use round brackets. Okay. So this is how I do it. Just create 2, 3 round brackets and put commas in between. So that I just know that here I will put something, right? Then in one thing I have to do is I have to first write some name. Okay, what I'm doing. So let's say I'm doing one hot encoding. So I'll write just as a OHE for short form that, and I will use one hot encoder, right? So I'll write that, put brackets, because uh, to call a class into object we require brackets, right? So that's why I put brackets, and then I have to give one array which will contain categorical column names, or column index also will work. Okay. So here names are there. So how will I give names? Uh, what I can do is I can just directly write names in a column. So, okay. So this all columns are there. I can just copy this all thing, okay, and put it here. Or what I can do is I can just write this also, this function. Both will work. You can copy it, this bracket inside this array, and put it here, or you can write this, and that will also work. Same thing I have to do with what is scalar. Scalar, I'm using mean max scalar because there are only years. Bracket, and we'll use this code. No, I won't use this code. Why is that? Because what I so as you can see, all the columns are categorical. Okay. except this order. So cells, we will not send it to any transformation. We'll just keep it like this because we don't want to transform this to something. Then predict it, then again retransform it back. Okay. I know that that technique is there. Something label transformer or something like that we do, but here we are not doing it. So that's why I'm not gonna pass it to any min max scaling or that kind of transformation. I don't want to do any transformation. So let's do it for these two columns. Okay, order here, order ship here. Where was that? Here, we make a bracket. And okay. Now I'll remove this extra. What am I missing? Scalar. In scalar. Okay. So now I'm getting TRF, and there is one more thing I have to do is pass through. Pass through. No, some other name. Remainder. Okay. Remainder is equal to pass through. So it will just pass through my output. Or what I can do is I can make extrain y train here itself, extrain y train here itself, and just send the extrain. And then I don't need to require to just write this, right? Because all the columns are already passing. But let's say if you're not applying any transformation on any column, then you need to write this pass through so that at least whole data stays whole together. It won't miss out any columns because except whatever I have written here, the columns which are given here, something will be applied to that and that will combine in the end. Okay, but if you don't write pass through, that means just keep that and remove other columns, something like that. So other columns will not come outside if you don't write pass through. So makes sense.
Sir,
Now,
for the
yeah,
just one question
yeah.
that where you use the D types exclude number, that
Yeah.
number takes everything, right? Int, float, it kind of considers
Yeah,
everything.
yeah, yeah. Int, float, everything. Yeah,
And
every number.
if for some reason it's a number but it is represented as a string, then what happens, sir? Like for example,
Uh,
it could be, let's say, pin code, but
okay.
it's a number, but it's actually should be treated as a string or something. Like, let's say it's a string. Then what happens, sir? I'm just curious. Like,
Yeah. Then it will not come in this. Like means then it will not detect it. Right. Then you have to manually put it.
it will even the question is, the if it is a string, it's a number, but it's a string. Then will it be treated as a number or not?
No,
In
no.
this,
It
will
will
it?
be treated as a string. No, it will not be treated as a number.
Okay,
So
okay.
so what
So
I do is for my yeah, I just write include also. Okay. So here I'm getting that this columns and this rest of the columns, numeric columns, it is making my whole. So basically, my whole data set is there. I just took for confirmation. Okay, I'm not missing anything. You see both the summation or union of this is whole thing, right?
okay.
Yeah, but if let's say if I miss something, or let's say if it is not able to detect any one column, then there is nothing I can do. I just have to copy this thing, this array, write it here, and whichever is missing, I have to copy it from here and edit something like that.
Okay.
I have
Okay.
to write the whole array,
Okay. Got
but
it.
because here it's working, so that's why I wrote.
Yeah,
Uh,
yeah. No, I just because a lot of times the
yeah,
data
yeah, I
some
understand.
represents thing, although it's a number, and we don't want anything to be done on that. So I was
Yeah,
just trying to figure out if it. Okay. Thank you. Got it.
yeah. So we can see that one hot encoding is applied on. Is going to get applied on this all columns. Mean max scaling is gonna applying on this three, this two, and remainder. Whatever is remainder is going to pass. So it is not showing anything, and it will not never show anything yet. I mean, in future, I don't know. I still might do it, but so here I always check that I'm doing the correctly or not. I know that everything is written here. Still, doing a confirmation is not a bad thing. Every time to confirm whatever the step you're taking, because reverting back is also a big. It's a little bit uh, not easy. Then what I will write is CT dot. What I will do is fit and also transform, right? Then I have to write name, that is train. And if I run it, let's see. That is encoders require their input to be uniform with strings or numbers. Got float and strings. The understood problem is related to this postal code. Okay. And so that problem is postal code. So let's see. What I mean is, what I am expecting is that is the correct thing or not. What I will do is I just copy this, remove, I'll remove the postal code and try it. Okay, then that is for sparse out all columns should be numeric or convertible to numeric. Yeah, hello.
Sir, hello.
Yeah, hello.
The data type for postal code is showing to be float instead of string, so that may be the issue.
Yeah, that's what I was thinking, and that's why I
No,
removed
actually,
that.
I just saw data.info. I did data.info, and there it's showing as float.
Okay. That's in this. It's integer, but postal code is object.
Okay, so in my it's showing as float.
Okay. For me, it's at least showing object. So, but then I removed that also. So I removed this object, right? So what I did is I removed postal code. Now I'm doing it again, and now the problem is something like this. For a sparse output, all columns should be a numeric or convertible to numeric. And what is not possibly convertible to numeric? What is that? Okay. This is possible. Other is also possible. Everything is possible. What is not possible? Okay, supplies. Okay. Okay. What if I write sparse equal to false? Why? Uh, so at least I'm getting output now. Uh, except postal code, it worked. Right. So let me add postal code here. Okay, string and float is not working. Then what I can do is if it's saying so what is it saying is float and string doesn't work. So let's say require the input type to be uniformly strings or numbers, right?
So we can
Uh,
replace
yeah,
other
we
with
can encode
zero.
it as zero. Yeah, other as zero. Yeah, that's what I also thought. Or null. I can do null also, and that will also work. For some reason, null works. But let's do it here. Or maybe let me remove postal code one. This is the one, right? It's not required. Right here. Now, if I see, let me get some. Now it worked. I got some array like this. What I will do is I will write pd dot data frame. Okay. Now I got 50 columns, around 50 columns I got. Okay. And do pd dot set function. Okay. What I have to write is display dot next columns. That's what I'm writing. Sure. Whatever. Work. Now we can see all the columns. So this my so this 50th one is now my output. Okay, everything else is 49, 58, something like that. So see, it's okay to use this thing, but there's one other way also. pd.getDems, right? pd.get dem. What I have to do is uh, train, right? Train, and I have to do columns. Columns will be and this will also work. Okay, you get sales order here, something, and you can see ship mode first, mode same day, mode second class. So if you ask me, I like pd.getDem is more than this column transformer or one hot encoder because this will give you at least some column names also, right? City, Chicago. So from city, I got this Chicago. From city, I got Houston. City, Los Angeles. So I know that from where these columns are appearing, what this column has meaning now after transformation. So here after transformation, it's very hard to you know judge what is where, which is which column I'm getting, which column I missed, or what it is like after transformation. But here I can at least know what is this, right? So this is from subcategory other. Okay, this subcategory furnishing. There was one subcategory before, right? Here. So from subcategory, it has come out. I know it is talk what it is talking about. So I like this pd.getem is more than that. Then I can apply, you know, this min max scaling on this too, and we'll get data as this only, like something like this. So it will be more beautiful, right? Yes, you know what you are getting and all. But for some reason in our course, they are using this one, and the reason behind is why we use this one hot encoding is so that we can build the whole pipeline. Uh, so you can actually build the whole pipeline. So when let's say train data comes in, cleaning or something like this. So this function which I made, you can apply that or something like that. There are things you can do with pipelines. You can make the whole pipeline, and then you don't have to worry about test data. That is very convenient. So there is also benefit of using uh, using this column transformer for that kind of process. But for while doing data analysis or what we are doing right currently, we're just looking the data, trying to go through it. Then at that time, this pd.getDummies is more useful in that way. So both has their importance here and there. But in course, we mostly talk about this column transformer and not this pd.getDummies. PD is pandas. Okay, so from pandas this is coming. Okay, so now we have data and all, but we haven't stored it anywhere. So let's say train data clean or something, clean or say number. Anyway, I'm storing it everything here. Now, can do is string is what is that string? If I remember string numeric, right? Then I have to use this I love and all the rows, but and all the columns except last one. Okay? So for that I'll use -1. Same thing I have to do almost same thing, not same. White ring. All the rows I want, but only last column. Okay, something like this I'll write. Then we'll do is string dot shape. If, t maybe because what was string numeric shape. Okay, it's 51. So let's see if I did the correctly or not. I'll just add extrain dot head, see few columns. Just for confirmation, right? That I did correctly. Okay, I did it correctly. Same thing. I just let's see by train dot head. Because the values are series or something like bigger than scaled one, right? So I know that these are output. Now everything I did, we are completed our cleaning and all. Great, right? All the process are done. Now we have clean data. We can now do is model training. We are there. Okay, we can do model training now. Model selection and training. So is there anything you want to ask now? Uh, because this is the most important part. Now everything is just plain, simple, like two, three things: import, fit, predict, or something like that. NP.where 10. Okay, thanks, Kevin. But I didn't show your comment, so I would have used that.
No, sir, I don't think so. It would have worked like how yours did.
Oh, okay. Uh, okay. Is there any questions? Any doubt? Session Q&A section. Which cleaning was important, right? After that, everything was easy. So okay, let's see where we reached in this. Okay, we did data samples, features, statistics. We haven't done this. Data statistics, right? Should have done this. But it's okay. Oh, no, this thing we did, but not this. Not this statistics. We should have done something like this. Okay, data visualization also I totally skipped it. But so this data visualization is, it doesn't contribute anything to our this model training process, but it contributes to how we see the data or how we are going to change the data, something like that, right? So let's say if you are seeing more number of data, some one type than other, then you know that data is imbalanced or something like that, right? So you will change some settings later on, or do equalization or something that will affect the model. But visualizing something is not going to change your model, right? So this train test bit will affect your model, yes, something, right? Something will change because you chose different parameter for this test size or random state or something, right? But just viewing something, a data is not going to change your model training, right? Or model or data cleaning or something like that. But it's going to change the output you got from that graphs. Stratify sampling can do something like this also, but that's okay. Uh, and sampling data visualization is here. So see, here you can see this code also, right? You have import cborn that sns dot scatter plot, then choose some x and y, and hue means color on that other feature, color based on some other thing, right? Then data is data name. Here we use df or df2 or train or something. That you have to do. I didn't do it, but please do it by yourself. Correlation. Okay, so this correlation is not important here. The Why is that? Because we don't have any numerical data except years, and years are also not really correlated. I mean, I use same year both, like both years are very similar. That's what I can say. I should have removed one more year. I mean, somebody was suggesting, and then that time I said I will remove it, but then I didn't. Right? Uh, See, order year, ship year, both are same, mostly same. Or I haven't seen it, but if I see now, let's see, DF2 order year dot is I write equal something. DF2 GF ship year. dot equals, okay, I just had to write it. False. Okay, it's not totally equal, but uh, there there might be somewhere where it's not equal, but mostly it is same, similar, same kind of thing, right? We can drop it, and we don't have that many numerical columns, and there's no numerical column. I can say that, and right, between categorical feature we can't get correlation. We require two numerical feature to get a correlation, right?
We should have taken dates rather than years, so that would make
Yeah, yeah. Dates, months, we might extract them. So that task I left on you. Like, you can do it. Okay.
yeah, sure.
Now, what other things was there? I hope this was a good, at least good problem set. I'm not sure about that, but there was too much reprocessing required, and we managed to get through all of it. So here, data visualization is there. Now, prepare data, label and training, data cleaning we did, handling text and categorical data, feature scaling, a pipeline. Now what is it? Okay, train and select and train models. Now we are here, select and train model. Okay, great. We did most of the things except data visualization, which you can do. Row pie charts, row, which will work here, categorical data, bar charts will work, right? Univariate analysis you can do. You can do bivariate analysis also. Compare one kind of category with another kind of category. See something like that, right? So in model training, mm, there is one thing which is feature selection. Somewhere cross validation is there, feature selection is there. Right? You can do feature selection now. So this is the place where we can do feature selection also. Where is it? Okay. Now this model training is coming up, right? Before model training, we can do feature selection, and then we can do model training. Okay. Uh, now time is almost over. Then we can do tomorrow or something. Tomorrow we have another session, right? 2 to 4. So what do you recommend? Let's do it tomorrow. Like there are too many. How many steps main? Fine tuning is also there. Hyperparameter tuning is also there. We can do it tomorrow. And randomized search series. We'll see that also. Okay, we'll see randomized search series and present your solution. Okay, we'll present it. No problem. So if like if you don't have any doubts with what steps we did, we can close this class, and from tomorrow we'll begin from here. Okay, we'll do feature selection and then model training. PCA also we will do. PC, let me write PC also. We'll do PC also. Is there anything I should also cover that also? Any suggestion? Not just go through this data. Okay, just comment it out. And I will share it with you also. Just Put the data set also. I will update on the sheet also. Okay, don't worry. Hello, Sam.
Sir,
Yeah.
where is that sheet, sir? That is not in supplementary content.
Uh, okay. Yeah. True. That is not in supplementary content, but there are two, three ways you can search it for it. One thing is, so let's say last session was on this 24th, right? Okay, not on 24th, but 23rd or something. So here, YouTube link here, it's not there. Okay, so what I did is, in YouTube, if you go, okay, and if I see playlist, so this is our playlist name. This is our playlist name, right? This sheet is the link for that. This link. Okay, if you copy this,
Okay.
okay, this one way. Another way is you can go to discourse, okay,
No,
and
got it.
you'll
This
get
is
that.
fair. This is fair enough. Got it.
Yeah, but on so I have updated.
I thought generally we keep it in our folder, like
True.
course.
The problem is whoever is configuring this term MLP, she is new to this all, so she is too much confused how to do this.
No
So
problem.
that's why
Got it.
we couldn't able to do it. But so what I did is I just updated it here, and it's also already in discourse, and somewhere else also we have put it. This not
Let us
here.
keep it updated. That's it. Let us keep it
Yeah,
updated.
it's updated, right?
Yeah.
Till
No,
since it's
last session is also not updated. No?
it's updated. For this collab is
Collab, yeah.
so what I was getting told is this same collab was used for this both session. So I
Okay.
didn't update for this. Yeah.
Yeah. Got it. Yeah. Balaji sir was there. Balaji sir was there.
Yeah.
Yes.
So if you want, I can just copy again and paste it here.
No, sir. No, that's fine.
Mm. I'll update mine also. But so this session link
Where
is
where
here.
is this file under the supplementary contents? Is it the link?
No. It is in YouTube. It is on YouTube only.
Okay, this is YouTube. This is YouTube, right? You can see
No, sir. Those collab files.
this collab files are. You can click it; it will open. I mean,
I
uh,
know. I know. Where is the link for that? Is my
this is the link, right? Just click it,
no,
and
no.
you'll
I
get.
mean, where is the? How do I go to the source of that?
Okay, so the sheet link you want,
Yeah, wherever that this entire all these four, five, six are there. Like this Google Sheet link.
this Google Sheet link. This Google Sheet link is in YouTube. This YouTube. This is the link description, and on Discourse also. If you go to Discourse, I'm not sure if I can open Discourse on this.
YouTube, MLBSC.
Uh, uh, I'm not logged in from Discourse on this account, but if you go to Discourse, it's there, right? And Discourse also it's there in wireframe or somewhere. Some question was asked that I updated this, but you can have it now. What's the big problem with it?
What is the YouTube handle called, sir? If you can just go back once there. As you,
CS2 certificate.
MLP T2 2020.
Okay, I can just share the link now. Well, this is the playlist. Okay, this YouTube playlist, and I mailed you already. Like this thing is already been sent to you. So if you go to this, right, where you get announcements, where announcements are there, inbox. Maybe, yeah. MLP live session content link. Yeah. So if you go here, you can see this MLP T2 2023. You open this, this is the link.
MLP Live.
If you go to your inboxes, you
Yeah,
can
yeah.
see
This,
somewhere live session content link. Okay. Session. It will be in your mails also. Gmail, which are mails used or something. Okay. I mailed you already. See, somebody. Accept. Now, is there anything?
so today's collab you'll add, right, sir?
I will add, but I also already posted the link in the this. Can you see? This is where the link is. This is
Actually,
the link.
I joined via the
Okay,
phone.
I'll update it. Okay, I'll update just now.
Yeah. I am doing it. Got it. Thank you.
Um, and I will update it just now. Okay, I'll do that, and we'll do this other steps tomorrow. Feature selection, PCA,
Right. Anyhow, you will be
anything
only
else.
you will be only continuing na? From tomorrow
Yeah,
also.
continue. Right,
Yeah, yeah.
continue. We'll continue this same data with same data.
Yeah, that's great. Then
So
also it
tomorrow,
will.
what session? What time, sir? Again,
2 to 4.
2 to 4. Yeah, that's okay. Thank you.
Hello, sir.
Hello.
Hello. Yeah, good evening, sir. I have a question. See, we are selecting only top 8 postal codes and top 5 cities, a kind of a thing. So
Yes.
you are talking about bias now, sir. So how are we going to overcome this bias when we are cleaning this up and training the model?
Uh, so there is one research paper, okay,
Okay.
in which it tells that if you have very high amount of categories, okay, and if you let's say take top some numbers of that number is uh, like but I chose randomly, but if you choose some like very few like top five, top six numbers, topmost, right? Then
Yes, sir.
you will be able to retain 95% of data, or it won't affect that much, something like that.
Okay. But
Research paper
here,
is
when we
like
chose this postal code, almost 8,000, I mean, 8,000 plus records came as part of others, no, sir. So, I mean,
yeah.
there is a huge amount of record which is coming as part of others. So, is this considered as bias or not? Still unbiased, sir?
I mean, we'll see when we'll train the model. We'll see if our model is giving out a good result, or at
Okay.
least somewhat reasonable. Then we have no need to worry about that. But if it's not coming out to be a good model, let's say if my training uh, whatever R2 score is coming out to be 60%, then I need to go back and change something. Like I can't do
Okay, sir.
it.
So
And
after
see,
training only we'll
and
be able to find it out.
yes, and sometime what happens is, so here we have too much categorical data. Like mostly all of the things are categorical. So for this kind of data set, like regression problems, and this is also regression problem, or any classification problem, even though the model doesn't work that the machine learning doesn't work that much. Like it's a limitation of machine learning, I would say. Then we have to go for maybe deep learning or something else. But if you have too much categorical data, machine learning models doesn't work that great. That's the limitation of it. Okay. Thank
Okay,
you,
sir.
question.
So it is okay if we just, I mean, if the system is working good more than 90%, it's 90, 95 as you said.
90,
Am I right?
80 is good. I mean,
Okay.
80 is a good number, I can say, but 60 is less.
Okay, sir.
If,
Okay.
if, if our model is coming out to the near 8, let's say 77, then also I will consider that what we did is at least in a good amount. Like let's say if I want to improve my score now, then I'll go back of course, I'll go back and see. I will try to clean in a different way. Let's say I choose 9, 8, right? Then I can choose 10 for everything. 10, 10, 10. Then see if it is improving by, let's say, 2, 3%. If it's coming about 80, then I will just, okay, now I am satisfied with my model or something.
Okay, sir. Generally, how much time difference will be there between when we train the machine learning model and when we go for deep learning, sir? It will be, I mean, huge difference of timing.
I mean, how come? I mean,
I
timing,
mean,
I don't
when
get.
we go for deep learning, the same model which we have done through machine learning, and
Yeah.
if the same model, if you're going to put it in deep learning model, so the time involved will be very huge difference, is it? I mean, just asking. I mean, how long? I mean, how much duration is really required for deep learning and for machine learning?
For deep learning, this is very small data, right? 8,000. It will be very easy for deep learning, but it is not that easy for machine learning because in deep learning there is like layers, hidden layers, and for everything there are different neurons, right? Something like that is a perceptrons. So so like that's why for deep learning, the small data set will be easier to predict, and it will, I guess, it will do other things also. In postal code, it will be able to handle, I guess, something like that is also already being handled by deep learning. Huge number of postal code. I mean, huge thing is not a problem for deep learning, but for huge things are problem for machine learning, right? I mean, huge means this
Yes.
huge, which is our data. I'm talking about in this sense.
Yes, sir. So that's I just wanted to understand because can we just go ahead with deep learning itself, or we have to start with machine learning and then go ahead with it's like how we shift. I mean, it depends on choosing the algorithm. Am I right, sir? If
Choosing algorithm is not right thing. So why is that? Because before model training, right? Before model training, nobody knows which model is gonna come out best. Really, nobody knows it. So what in practice everybody do is they train all the models. They just train all the models and see which is coming out to be better. Then, which is coming out to be better, let's say top three or top two, then they do something on that. Okay, hyperparameter merging, staking, uh, some this kind of techniques they use, and then they try to improvise their models. Okay.
okay, sir. Okay, sir. Got it, sir. Thank you, sir. Thank you for explaining it in
So,
detail.
sure. Okay, guys, should we drop off, or is there anyone have any doubts?
No, sir. Thank you. We can discuss tomorrow.
Okay.
Okay.
Uh,
Thank you, sir. Yeah.
Bye then, everybody.
Bye. Bye, sir.
Bye, sir. Thank you, sir.
Yeah. Uh, sure. Bye. Thank you.